Good morning and welcome to this video solution on NCRT exemplar program problem. Very interesting problem, and let's do this. And again, I will first explain you the concept. No website, no application, no portal will give you this explanation which I'm giving. Okay, so listen to this very carefully. My first focus is to make you understand what's happening and then solve the problem. I can solve this problem in 2 sentences, but I will take some time to make you understand what's really happening. So let's go ahead with solving the problem. Okay, so you understand the question is, so what you've done is read the question very carefully first. There is a glass block. Okay, this is your glass block, and what you've done is you have placed a pin on the face AB, right? This is very important. So it's placed on the face AB. The diagram shows it's something like away from AB. It's actually placed on AB, right? So this is your A, this is your B, C and D. Okay, now for you, so the question is, where will you be able to see the pin? So you can either see it close to A, or can you see it close to D? That's a question being asked, right? For you to be able to see the image from A side or D side or at the center of AD, not seen at all, the emergent ray, right? The emergent ray should emerge out, right? So this is your normal, and the bending has to take place, and these are your eyes, right? So your eyes are here, you're able to see it, right? We need to justify what will happen when the ray of light strikes at AD, and then whether it emerges out or not. The second case is the ray does not emerge out like this, but it goes and strikes it, and there is a concept of critical angle. Critical angle is the angle when a body moves from denser to rarer. This is very important to understand. Denser to rarer, right? So if you look into this problem, you have this place where you're inside the denser medium, because this is a denser medium, right? If you're inside a denser medium and this is your ray, right, it has two possibilities: either it emerges out or it goes inside, right? Because it's inside, it happens. The concept of critical angle is associated with what is called as total internal reflection. Total internal reflection. The body will get reflected inside if the angle of incidence is greater than the critical angle. So if this angle, which is the incident angle with the normal, this angle is the angle of incidence. If this angle becomes greater than critical angle, the ray will come out, get back inside the medium. This is called total internal reflection. So again, this is your block. Two possibilities: the ray goes like this, normal, it bends, it comes out. The second scenario could be, and this is a scenario where the angle of incidence being referred to is smaller than the critical angle, so the real refraction happens. So here the refraction happens. Okay, but the scenario could be the ray of light comes, right? This is the body, so there is no ray here. The ray is actually here, and this angle, then this particular angle is greater than the critical angle, so the ray goes back, right? This angle of incidence is greater than the critical angle. So this is the situation of total internal reflection. In case number A, you will be able to see the pin image, right? So the pin image will be visible to you, right? So the pin, because the ray is emergent. But in this case, no image. In the case number B, since the ray has gone inside the denser medium, this is a ray, this is nothing, ignore this. The ray has gone inside, and therefore here, if you keep your eyes, nothing will be visible. Nothing will be visible. In fact, when the ray of light strikes here, if it strikes at an angle which is less than the critical angle, it is again moving from denser to rarer, so it will move away from the normal. This is your normal. The ray of light moves away from the normal, so probably you should be keeping your eyes here to be able to see this image. So the pin was here, your angle was greater than the critical angle, total internal reflection happened. Again, I'm applying a Snell's law here, right? Again, I'm applying a Snell's law. The body emerges on this side, right? So this is the way you first understand the concept of total internal reflection. Now, total internal reflection and the refractive index are associated with each other, right? So mu is equal to 1 upon sine C, where C is the critical angle. This is something you must remember. This expression should be known to you, that the refractive index and critical angle are associated with each other in this manner. Now let's solve this problem now. I hope the concept of total internal reflection is clear in your mind, but this question is a bit tricky, so therefore listen to the solution part of it very carefully. The basic concepts I have reiterated for your benefit. So let's say you have this block. Now it's a square. Okay, it's a square. This is your pin. First consider the midpoint, and I'm again telling you, no one has given this explanation. Okay, this is the midpoint. Draw a line from the point pin to the midpoint. Now if you draw this at the midpoint, okay, let me redraw this. This is what I'm trying to do. So this is your midpoint. Join it to the other midpoint and measure this angle. So this is 90 degrees. This side and this side are equal, so this is 45 degrees, this is 45 degrees, and therefore the angle which is made by the incident ray with the perpendicular is 45 degree, right? This is 45 degree. Why did I do this? Because if I draw another diagram, let me show you one more diagram, okay? If I draw this diagram, this is again the midpoint on the face AB. This is my midpoint. If I draw a line here, okay? If I draw a line here, what will happen? This is the incident ray. This is my normal, okay? This is my normal. And the angle which is being measured now, right? You can see this angle is smaller than this angle. So this angle is now less than 45 degrees, right? This is less than 45 degrees. So this angle, right, will also be less than 45 degrees because these are parallel alternate angles. So this angle is also less than 45 degrees. I'm talking about the midpoint right now, and there is a reason I'm doing that. Let me draw one more figure, okay? Let me draw one more figure. If I draw this figure, this is your pin. If this is your point, and if you again join these two, I draw a normal, right? This particular angle as compared to 45 degrees, look at this angle. This is 45 degree angle. So 45 degree angle, and this angle therefore will be much larger than 45 degree. So the moment you go below the midpoint, so assume this was your midpoint, okay? I'm just redrawing this. This was a midpoint. Doesn't look like, but assume this is your midpoint, and therefore this was 45 degrees. So I'm referring to this figure. Now I have drawn another point here below the midpoint. This is midpoint, so I've drawn it below the midpoint. This angle you can see is much larger than 45 degrees, right? So therefore this angle, and this angle is greater than 45 degrees. So this incident angle. So if you go below the midpoint, right? If you go below the midpoint, your angle is greater than 45 degrees. If you go above the midpoint, your angle is 45 degrees, less than 45 degrees, right? I have proven this to you. This is the concept you have to memorize. Not memorize, you have to understand this, because this is based on basic geometry, okay? This is basic geometry being explained, right? Now what is going to happen is, if you draw this figure, right, let's move to the next step. Let's draw this figure. There is a pin. Now mu is equal to 1 by sine c. Sine c is equal to 1 upon 1.6. If you calculate this critical angle where the total internal reflection will happen, this comes out to be around 39 degrees. This is approximately, okay? Approximately. So if your angle of incidence is greater than 39 degrees, then the total internal reflection will happen. So if I were to take my situation, this is my situation of 45 degrees. This is my situation of 45 degrees. If I go above this, okay, a bit, so this is 45 degrees. 45 degrees. If I reduce the angle by 6 degrees, okay, I reduce the angle by 6 degrees and say this particular angle is now the angle which I'm referring to, right? It strikes at this point. The angle which is getting created with the normal is now 39 degrees. This particular ray will come back because maybe this at 39 degrees this will graze, right? I have already explained the concept of grazing. The moment you cross beyond 39 degrees, this will start coming back, right? So a total internal reflection will happen. So if the angles are less than 39 degrees, the ray will emerge out at 39. So this is what will happen. So if the angle is, if this is your point, this is 45 degrees. If the angle, and 39 degree is getting created here, right? The smaller angle you can see, right? The grazing will happen here. If the angle goes below 39 degrees, the rays will start coming out. So rays are coming out. So rays are coming out. Ray coming out. This is grazing because the angle of incidence is equal to 39 degrees, is equal to critical angle. And beyond 39 degrees, if you increase the angle beyond, so this was the angle of 39. If you go, for example, 43 degrees, it will come back. Any angle. So this angle anyway is 45 degrees. So between this point and this point, the angle is between 45 and 39 degrees, right? So you can always say that beyond this particular point, which I'm marking as 39 degree point, all other points you strike below, the angle becomes greater than 39 degrees, and therefore total internal reflection happens. Now let's get back to the question. The question is, what is the probability of you being able to see the image at A or D, right? If you have understood what I've explained to you so far, okay? If you have, let me just create more space and make it clearer. If you have understood what I've explained so far, right? Okay, so I've explained you a point which is 39 degrees. I've explained you a point which is 45 degrees. And then of course, any point greater than 45 degree will mean total internal reflection. This is 39, so therefore grazing happens. This point is less than 39, so internal reflection doesn't happen. It goes out, right? It bends towards the normal, right? So it bends towards the normal. This is grazing. This is 45 degree. Internal reflection happens. Anything which is greater than, for example, this is 41 degrees. Internal reflection happens, right? So you can make out that the closer you are to A, your angle is less than 39 degrees, right? Intuitively, although the exact point is not visible, but you can sensibly see that if this is your point of 39 degrees, the angle of incidence is 39 degree where grazing happens, right? If your point is, this is your 45-degree point, and this is your 39-degree point, any point which is above this is closer to A. If you are closer to A, your angle of incidence is less than 39 degrees, and therefore the total internal reflection cannot happen. But the farther you move towards the point D, higher is the probability. It's that your angle of incidence is greater than 39 degrees, right? So the answer is you will be able to see image while if your angle of incidence is closer to A, you will still be able to see the image till here. So this is the 45-degree mark, this is the 39-degree mark. So you will be able to see image closer to A side of things, right? You won't be able to see anything towards D side of things, because we've proven as you move towards D, you're anyway greater than 45 degrees, right? This could be 75 degrees, and this could be even more. So I just joined these, okay? This is again much higher in terms of angle of incidence, right? So I hope this is making sense to you. So closer to A image is possible because then you're moving less than 39 degrees, and if you move beyond this point, which is 39-degree mark, towards the 45 and beyond, all the way down, your angle of incidence is greater than 39 degrees, and therefore the total internal reflection will happen, and the image will not be visible towards D. No channel in the country, no application, no portal will give you any explanation of what they have written. You go to a website, they will straight away write this, making you believe you've understood this. But unless you have deeper understanding, you will never be able to grasp the concept. What I've told you has multiple levels, and any examiner will test you at multiple levels. They will not test you based on solutions you have memorized. Spend time on watching my YouTube playlist for ray optics. Excellent concepts given, excellent explanation given in such a manner that will stay with you forever. So don't waste time on applications and portals that don't explain. This coaching, sitting at the comfort of your home, is helping you understand physics better than any classroom, any application, any portal. Don't miss an opportunity, to watch the next video. Again, an explosive video is going to come, which will, help you understand one more concept. I hope you enjoyed this video. If you did, please like it, and don't forget to compare this with any other solution you would have seen in any book or any website or any application. You will see the difference on your own, and that should be the reason you should subscribe to it, because you prefer watching explanations to solutions. Thank you very much for your time today. See you on Monday now. Bye.